Hello, today we're going to do a problem that uses ASCII. And don't worry about what ASCII is if you never heard about it before, because I'm going to talk about ASCII in a bit. And I guess we're not directly using ASCII, but this problem is a lot easier if you know how integers and characters are related in Java and in many other languages actually. If you already know what ASCII is, great, just go ahead and start doing the problem. But otherwise, I'm going to start talking about ASCII. Alright, so ASCII, how do I start? Alright, you see computer hardware can only understand two characters, zeros and ones. So whenever you type a character, let's say you type character A on your keyboard, then the computer must first translate that into a bunch of zeros and ones. The standard that we use is called ASCII, and that is ASCII. And on this ASCII table, you can actually see how each character is translated into a binary string, that is the bunch of zeros and ones. So for example, capital A is 0, 1, 0, 0, 0, 0, 0, 1. And small case a is actually a different character, and it will have a different representation. I guess so, it's over here. Yep. It's going to be 0, 1, 1, 0, 0, 0, 0, 1. Of course, it's very cumbersome to say the binary expansion all the time. And we know that this binary expansion corresponds to an integer. So we can say that A is just 65 and small case a is just 97. So there is a one-to-one correspondence between each character and a decimal number because they have the same representation in the computer, as in they have the same binary expansion. And in languages like Java, C, C++, other languages, you can use them interchangeably. What do I mean by this? Well, simply that when I declare a character, I don't actually have to put in a character. For example, we would normally say character ch equal to capital A, for example, and let's output it. Okay, I should get an A. Yep, there's an A there. You can instead use a decimal number, which is the representation of A. So we saw that A corresponds to 65. So if I put in 65 there, this will also produce an A. And what's more is that you can do arithmetic with characters. So I can do 65 plus 1. What is 65 plus 1? 66, right? And when I output it, I'm going to get B. So I'm not going to get A plus like the character 1 like you would get on a string with plus, but I'm actually going to do 65 plus 1 first. I'm going to get 66, and that corresponds to a character. And you can do funny things like, let's do A plus E. Output that, and I'm going to get a question mark because that's a non-recognizable character. So that's probably not a good idea. I'm trying to think what I can use. So if I do A plus E, it's actually doing 65 plus 69, which is 134. And what is 134? Something, well, it's beyond 128 actually. ASCII normally only goes to the first 7 bits, so only up to 128. Let's do something else. Let's try to do, okay, here's 33 and here's 32. So what is 32? 32 is SP. SP is actually space. So I'm going to give the space character here, and 33 is the exclamation mark. I'm going to put that there, add them up together, output it, and I will get A, which is 65. So I hope you now see what I mean when I said characters and integers are interchangeable. Basically, you can treat every character as just an integer, which means you can do operations like add, subtract, multiply, divide. Although when working with characters, you probably only want to do add and subtract. Now we're going to use this to solve the key to cryptography problem. If you haven't seen the problem yet, maybe just give it a quick read now. The link is in the description as usual. Just pause the video. So this problem basically shows you a very simple encryption scheme where each character is just shifted to another character. So for example, here's the plain text, or the message if you like, and here is the key. So according to the question, A corresponds to the number 0 and C corresponds to the number 2, And the way the key works is that you're going to shift the original message by this many characters. So for example, S is going to be shifted by 0. So it's just going to be S, well, because you're not shifting it. E, on the other hand, is going to be shifted by 2. So E goes to F and then goes to G. So the ciphertext will contain G there. Now N we are going to shift by M. So what is M? M is, so J is 10, KLM. So M is 13, which means that N is 14. That gives you 27. Oh wait, sorry, we start at 0. So 8 is 0, which means J is actually 9. So M is 12 and N is 13. 12 plus 13 is 25, which means that is Z. Okay, so good, I agree with this. And as you can see, that wasn't that pleasant to do on my head. So you can actually do that here. M plus N. Now, if I just run this, I'm going to have the same problem I had before, in that I'm going to get some funny character, right? Because M, if you remember, is, what is M? 77 and N is 78. So no, that's incorrect, because you're going to have a very big number. You're not supposed to shift by 78. You're supposed to shift by only, what was it? 13. So how do you get 13? How do you get that? Well, the reason why N is only 13 is because A is only 0. All right, but A here is actually 65. So how do you get 13? Well, we just have to do N minus A in the program. So now if I run this, I should hopefully get Z. Great. So hopefully now you have some idea on how to do this question. And you can try to give it a go. So it's not as simple as making the ciphertext though. It's not like the question will give you a message, give you a key, and then ask you to make the ciphertext. No, the question actually gives you the ciphertext. And it gives you not the key, but just the start of the key. You see the key is built from the original message. So you have to figure out the key on the fly as you go. Okay, you're given the ciphertext, you're given the first 3 elements of, well, first 3 characters of the key, and you have to work backwards to produce the message. So you can probably try to give that a go yourself now. I think you know enough with after me showing you this character manipulation, or well, character arithmetic if you like. And I'm going to start writing the code very soon. So pause the video if you want to give it a go yourself. Okay, so let's get started on the code. Let me just move this here a bit. So that's going to be my input, and I have to output send more monkeys. Okay, so let's start by reading in the line. I'm going to read in 2 lines. I'm going to need 2 strings then. Let's say string input equal to in.nextLine, and string key equal to same thing. All right, so we have the input and the key. Well, actually, maybe I'll just call this cipher. All right, and then we're going to go through the cipher character by character. So I need a for loop. I don't actually care about how long the key is. All I care about is the length of the cipher, because that would be the length of the message as well. So cipher.length i++. Okay, so now we're at the first character, cipher char at I. What do we do with it? Well, we're going to need a string message to store the answer. So I'm going to start with an empty string there. Okay, now we're at the first character. We got S and we got A. We know the first character of the key as well. How do we get the message? How do we get the first character of the message? To get the cipher, you have to add the first character of the key to the first character of the message. So if you want to get the first character of the message, you have to subtract the first character of the key from the first character of the cipher. So we have to do minus key char at I here. This is how you always get the message, right? And that would be the first character of the message. So I'm gonna say message equal to message plus that. And this is pretty much the main thing that you have to do for this question, but there's a lot of problems here. If I try to output it, you'll see. So, okay, maybe a problem that you can already notice is that this is wrong. You saw this earlier, that you're going to be subtracting too many because we have to adjust the key by A, as in, you know, remember that C is something like 67, so if I try to do that here, I'm going to subtract 67 from the first character, which is wrong because I'm supposed to subtract only 2. So I have to adjust that by A, and I'm just going to do that by saying minus A here. And the second problem, you're going to see if I run this. Let's just give it SGZ and ACM. I get numbers because this, the whole thing in bracket, is treated like an integer. If you want to actually produce a character out of it, you have to say I want a character. So I'm going to put that there. Okay. And why are you complaining? Oh, because I have an extra bracket. And then, no, you're still complaining. Sorry. Key chat. I do need that bracket. Oh, I have to cast it. Well, that's kind of useless then. Sorry, I did this in C++ where I didn't have to do that. I guess, well, let's just go back here, and I'm just gonna put a cast here. I'm not sure if there's a better way of doing this actually. All right, but just keep it like that. Let's try to run this. SUZ, ACM. I get SEN, which is correct because, well, we need to make send more monkeys. At least I got the SEN correct. Of course, if I just give it the full input, this program is going to crash. Why? Because right now the key is only 3 characters long. So it's going to die when I gets to 3. We actually have to build the key as we go. We have to keep on appending the character from the message to the key. So actually, now that I think about it, it's actually better if I do use a new character for this. So apologies, I'm going back to this, and then what we're gonna do is we're going to append that new character to the key. So key is equal to key plus ch, and we're also going to append that character to the message. So message is equal to message plus ch. And let's try to give it a go. Let's run this. Okay, give it ACM. Send more. Okay, close. We're getting there. We're getting there. We got the length correct. We just, what is this garbage? You see, what we've done here is that we take a character from the ciphertext. Let's say we take H, and then we reduce it by a number. Let's say reduce it by 2, by 3, so maybe H becomes D or something. But what if I take H, like the number 72, and then I take away something like 15? It can happen, right? Because you can have Q, I don't know what sorry, B, I don't know what costs you to get a 5, but what is 5? 5 is, let's go down, 5 is 53, and B is 66. So you can actually get B minus 13, and the value of B is only, well, you don't want to, you need to handle that. You need to handle like wraparounds. So B should go to A, and if you want to shift to the left again, you have to go to Z and Y, X, and so on, right? So you should get E actually, instead of like, just send me more monkey, right? Yeah. So how do we handle it? How do we take care of that? Well, the easiest way to handle this is probably by saying that if the character is less than 65, less than A, then you're going to shift it to the right. So let's say the character is actually 64. You know what 64 is minus 1, and that should be Z, which should be 90. So how do you get from 64 to 90? Well, you add 26 to it, which is the number alphabet. Like you have to offset it by 626. So we can say ch plus equal 26. And let's run this now. What's the input? Do I still have it? Copy, paste, send more monkeys. That's how you do it. Of course, there are other ways you can do this. For example, let's use example. Let's say I want to do B minus 5. Well, B minus E. Okay, so this should give you, what is it anyway? E is correspond to 4. So you'll be looking at A, Z, X, Y, I think. No, wait. A, Z, Y, X. It's hard to do this backwards. Anyway, how I would do this is by, well, let's look at the numbers they correspond to in terms of 0 to 25. B corresponds to 1. E corresponds to 4. So you're going to get minus 3. Okay. You don't want minus 3. Doesn't exist. You actually want 25, 24, 23, 23, or 22. But what I can do is I can say 1 plus 26 minus 4. I mean, it's the same thing, right? I'm shifting everything to the right by 26. So what would that give me? That would give me 27 minus 4, which is 23, which is what we want. So adding 26 will make sure that we'll never get a negative number, which is something we don't want. However, if you have something like G minus E, this time G is actually bigger than E, you're going to have a number which is bigger than 26, which is also a problem because you can't go beyond 25. What is G? G is, F is 6, G is 7, so G is 6, so you have 6 minus 4, and if I use the same formula, I'm going to get 6 plus 26, which is 32. 32 minus 4 is going to be 28, and there is no character 28 because it only goes up to 25, right? So how do you fix that? This should actually be 2. Well, it's actually not that hard. You just do modulo 26 on it. And also here with 23, if you do 22 modulo 26, what you're going to get? You're still going to get 26. So all you got to do is you get the first character, you add 26 to it, you subtract the second character, and then you do the whole thing modulo 26. And you will always get a number between 0 and 25. And that number between 0 and 25 tells you how far away it is from the first character, which is A. Like 0 gives you A, 1 gives you B, and so on. So if we do that here, I'm just going to comment out this part. Copy that. I'm going to say this one plus 26 and equate that. And the whole thing will be taken modulo 26. So take 26. And then I'm going to offset it by A, because that's the starting point. Okay, so let's do this one more time. This part here will give me a number between 0 and 25. Sorry, I forgot the modulo. So this whole part here will give me a number between 0 and 25. And that corresponds to a character from A to Z. But of course, in ASCII, A doesn't start at 0. A starts at 65. So I have to add A to it. I have to add 65 to it to get a proper character. If I run this again, ACM, it still works. So I'm going to submit this. Hopefully there's no other complications. Where's the submit button? I really need to zoom out. So Java, paste that, main, and I hope that is it for this question. Please get accepted. Yes, 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 yes. Okay, great. So the main takeaway from this question is that how to handle characters and integers at the same time. That's not a good way of saying it. It's like, how do you, yeah, it's like characters arithmetic. Like, you can't treat characters as integers. And the basis of that is this ASCII table. You can look up ASCII table online easily, and there's like, there are like lots of resources. Just type ASCII and you get it. But yeah, that's the problem for today, and I hope it's been useful to you, and thank you for watching.